file new project. File new project. It's not playgrounds. Objective-C doesn't work in playgrounds. So project, what sort of project we'll create? Actually, I just created the project already. No, I haven't. It's not iOS. Go to macOS. So macOS and click on command line tool. So macOS command line tool. Click next. And make sure the language. So here's the first Objective-C thing we'll be doing. So most likely your language by default right now is Swift, right? So those are the languages you could compile in Xcode. You have Swift, Objective-C, C++, and C. We'll do Objective-C today. For the project name, we could give something like Objective-C intro.
Wait, did you say command line tool for the thing?
Yeah, command line tool. So can I cancel out of this? Let me go back. So file, new, project, macOS, command line tool. That's what we started off with unit 1, day 1, when we did Swift. But the language was Swift. So here, command line tool, next, and then Objective-C is the language, and the project name, I'll just call this intro or Objective-C intro. Objective-C intro, something like that. Or maybe playgrounds. Intro is fine. You could name it anything you want, but try to name it something that is easy to get to. So Objective-C intro, click next, and I'll save it to my desktop, that's fine. And here we are. And where you want to click on, you see main.m, everybody sees that? Yeah, so click on main.m. I'll double click, make my window bigger. I'll change my font size to something larger, like this. This is fine. And there we are. Okay. All right. So here we are. We'll use this main file as the place to get our hands dirty with Objective-C. I'll talk about high level what we have on screen right now. Here we import foundation. We know about import foundation in Swift. For example, in Swift, we would do something like import foundation and be done. Already we've seen Objective-C is more verbose, right? You have this hashtag here, import. You have this angle bracket, foundation. You have this / foundation.h. .h means header file. We'll come into seeing what that looks like, hopefully today or next week. But basically the header file is what defines the functions and the properties and all that stuff. So that's where that lives. We have our in.main, that's a function. It has arguments. You could pass arguments to it, for example, if you're running this in terminal. And then you have this auto release pool here, which basically for now, just know that it takes care of memory for us, okay? And inside of this block, we have our first line of code here. Well, we have our comment, but we have our first line of code, which says NSlog hello world. What does that really do? What does that look like in Swift? In Swift, one second. In Swift, NSlog is basically print hello without the semicolon. So in Swift, this is what our code would look like. Just print hello world, string literal. But in Objective-C, NSlog, again, NS stands for next step. So NSlog, for a literal, all string literals have to be prefixed with an @ symbol like this. And then you have your string literal, your open quotes and your closing quotes. And everything needs a semicolon. So if I remove the semicolon and I build my app, it will tell me expected semicolon. This is not going to compile. Okay? So that's where we are with Objective-C. All right, let us go chronologically through our lesson now. Any questions so far?
That at main, where it says that's int is like initialize, or is that's not like an int, right? Like
what line am I talking about?
Line 12.
Line 12. So int, yeah, int main. I heard at main, sorry. So this returns an integer. So when we have our function, like, I guess I'm gonna jump in ahead here, but if I have a function, I declare a function here. Actually, let's just do that, I guess. Let's declare a function. And this function is going to be a C style function. We'll come to that later, but this is a C style function. Now, if I declare a C style function, like in Swift, our function starts like this. We have func, I could have add like this, right? And then if I return some sort of value, I would have int like this, and I could say return 5 plus 10. And then if it takes arguments, I would have like num1 is some sort of int, and then num2 would be some sort of int. And then I could say return num1 plus num2, right? So that's Swift. Everybody with me?
Yes.
Okay, so that's giving us errors everywhere. But in C, in the C language, not Objective-C, but C, I could write a function like this. So that'll answer your question. My return type comes first, same as we have main here. So if I want to return an integer or a Boolean, that data type comes first. Everybody with me?
Right.
And then I'll have my function name. In that case, I'll say add. I'll have my parameter list like this, right? So far, the compiler is happy. Actually, it's not happy because I need to return something. Everybody with me?
Right, return int.
In our case, we'll say we want to add two integers. So we'll say int num1, and we will say int num2. And then we'll just say return num1 plus num2. Okay. And now, again, this is a C style function. We'll come into Objective-C type functions. Everybody with me? Okay.
Right.
This here is a C function, not Objective-C. Okay. So now if I want to use my add function, again, my function is outside this function. Those are two functions I have now. One is called add, one is called main. So if I want to go ahead and use our add function, I need some sort of result, right? So that result will say int result, and we'll call our add function. It takes into integers. We'll just add 10 plus 12, just like that. Don't forget our semicolon. And now we want to print what the result is, right? Anybody want to tell me how to start doing that?
NSlog.
NSlog.
So NSlog, that's a good place to start. Okay, cool. What else?
Oh, I know this one. I read the thing. I guess this is going to be.
So we're going to say something like the result is whatever the result is.
You can't just say result, right? Because you're printing out.
Yeah, we cannot just say result. So we want to say this is what we want our output to be. Like the result of addition is, in that case, we have 22, right? We want to print this, and the result would be 22.
Okay, so maybe start with the at quotes.
At, okay, quotes, that's good. So now we valid, we have a string.
And then you'll type in, start with like that, the result of addition is.
The result of addition is, now in Swift, we'll do something like this and we'll be done. Yes, we'll put our result in here and that'll be awesome. But Objective-C, we have to use a format specifier, basically like a placeholder. If anybody has used, I know we have, if anybody has used like string format in Swift, you know, in string format, like if you want to format a decimal, for example, or like a floating number, you pass in some format type, right? Very similar here, you have to pass a placeholder. It starts with a % sign and whatever the data type is. In our case, our data type is what? What type of data type is our result?
Int.
It's an int. So I for int. And now I could put a comma here and pass in result. So what happens is at compile time, the compiler takes the value of result and it places it in this placeholder token here.
So if you wanted to print out,
Go ahead.
Oh, sorry. What if you wanted to add the period after the result?
Oh, we can. We could put it like this.
Oh, okay.
Yeah, definitely. Yeah, that's same period there. Very good question. And you could put more. You could put more characters here. But this one is a specific format specifier.
can you escape it for some reason? Can you escape it for some reason?
I mean, if you mean escape it, which sense?
In this, like you want to use that as an actual string literal rather than a placeholder.
That's a good
format
question.
specifier.
Let's see. Let me run it and see what it gives us. Run again. The result of addition is it didn't escape it, actually. One.
Okay, so wait, it didn't even print out the.
It printed it.
Print out the dash,
No, it didn't, because that's an escape character.
Oh, okay.
So the result
you'd have to escape the escape in order to get.
Exactly. All right, so there we are. The result of everybody got that? The result of the addition is 22?
Yes.
Okay.
Yep.
Any questions so far?
I have a question. So
Yeah, go for
if
it.
you're using multiple integers inside that slug, would you still have to like repeat the percentage
formatter?
I multiple times for the amount? Yeah.
Yes.
Oh,
So
okay.
we could actually maybe try it right now, right? We could do result. So result, and we could do percentage I again. Let's just do a comma and run it. I, not 1. So we have the result of result is result. The result of addition is 22, comma 22.
What did you call that again? The %I is a.
Percent I, that's a format specifier. So %I is a format specifier. And I stands for integer. We also have other types of specifiers. We'll actually take a look at one now, another one now. Nima, you had a question?
No, I was just saying yes when
Okay.
you asked if I got 22. Sorry.
Okay, cool, perfect. Great, so this is where we are. Let's keep going. We actually jumped into functions really quickly with one's question, because one's question, to repeat one's question was, what's this int doing here? This int is a return type, and main is the name of the function. And then we have our parameter list. So at the end of the day, you'll see, yes, the syntax at first seems a bit intimidating, although we haven't gotten into like the square brackets yet, but you know what functions are, you know what return types are. So you coming in with Swift knowledge already. So that translates to any other language you learn in your software career. All right, let us keep going here. Let's take a look at string.
Alex,
Yes.
how come it's only int and like not NSint for that one?
NSint. There's no NSint. There's NS integer. So NS integer that Mr. Sirin just brought up. So NS integer, I like how we're jumping around here. This is good, right? NS integer is a wrapper around integers and longs. Sirin?
Yeah.
It's a wrapper around numbers or number types like integers and longs.
Okay. Because I know like Objective-C uses like NSstring, like NSArray, and I was just wondering why it's not like NSint.
Yeah, like here you have an int, which is a primitive type, or you could have an NS integer, which is still going to be some sort of like I could have number here, and I could have 10, for example, right? And if I want to, so this NS integer, let me actually show you what NS integer looks like as far as the documentation goes. It's a wrapper around NS value, NS integer. So here, it's a type alias, right? We all know what type aliases are.
Yeah.
So here it's like a type alias around a long or an integer. And I think on watchOS, it's an int, or it's treated as an int. At least I saw that somewhere. But it could be treated as an int, or it could be treated as a long, based on the platform. Everybody with me? So to go back to Sering's question, I could use an NS integer here, as opposed, like if I want to write more Objective-C type syntax, I could say NS integer, but that's a wrapper. At the end of the day, it still goes down to a primitive integer. Sering, does that help you?
Yeah.
Okay,
Makes
cool.
sense.
Cool, very good. All right. We said we are going to go to string. So we just took a look at functions. We took a look at printing result values from an integer. Let's take a look at a string, right? Cool. So let's start off with, how do you declare a string? So here we want to declare a string. To declare a string in Objective-C, here we'll start off with NSstring, right? The data type always comes first. As opposed to Swift, again, we'll start really enjoying Swift, because in Swift, I want to declare a string. I just say name Bob. Name Bob, and I'm done. That's a string. Now, Objective-C, we want to declare a string name. We start off with NSstring. So far, so good. We need to have this asterisk here, which I'll explain right after I say what name. And then I will declare some string with a name in there. Alex. Okay, so here we declare the string. Let's go through the syntax of this. So NSstring is a data type, right? There's no string here. It's NSstring, NS next step string. I have my asterisk here. It says name is a pointer to a string, to an NSstring rather. It's a pointer. When I say pointer, I'm talking about an integer, int, is on the stack. Like a function is on the stack. We spoke about stacks in Swift, but basically we have our stacks. Like a function gets called, it gets placed on the stack. Everybody with me?
Yeah.
All right. If I declare a string, an NSstring is a class. Anything that's a class object goes on the heap. It goes on the heap. There's memory allocated for it on the heap. So we could probably put that in there. So NSstring is an object that allocates memory on the heap. And heap is just a place in memory, right?
I have a question.
A place in memory or a buffer. Yeah, go ahead.
So does that mean that classes are more memory intensive than stacks
Yes.
or structs?
Yes, yes, very good. That's a next question you could answer an interviewer. They take up more memory than a struct. That's why Swift UI is more, is faster, because most views are in, all the views actually, all views are structs in Swift UI, right? That's why you're able to create multiple structs every time you have like a state object changing, because it takes less memory. Well, it doesn't take heap memory. It goes on the stack.
Thank you.
Very good. Very good question. So classes are heavier, right? And as opposed to, so an NSstring is a class in Objective-C. What's a string in Swift?
Struct.
Collection.
Structs.
Yeah.
Not collection. Well, a string is a collection, but
Collection.
as far as like, is it a class or a struct? It's a struct, right? So if we go and take a look at NSstring here. We'll see it's a class, right? And if we take a look at, if I just change this, will that just change for me? No. gotta click one more, that's fine. And then here we have a string in Swift, it's a struct. Okay?
Mm.
We'll learn a lot more and appreciate a lot of things as we're taking a look at Objective-C. Already we're seeing the differences really quickly here. And if anybody remember back when I spoke about NSCache and why NSCache only works with NSstring is because of that exact reason, because NSCache expects a class type and string is a struct. Everybody with me? Right? Cool. So we have our NSstring, and then we know what that asterisk is. It's a pointer to memory, and that memory is holding an NSstring object, and we have our literal Alex. Okay,
So
go ahead.
I don't get, if we're already telling that what's gonna be that is a string type, why do we need the at next to the string literal?
Well, right here, that's just syntax, right? Similar as like, why do we need a quote?
Oh, okay.
Right? In Swift, you need two quotes to define a literal string. In Objective-C, you need an at with two quotes to define a literal string. It's just syntax, right?
Okay.
Cool, good.
But what does literal mean?
Literal means you're creating something that is that thing you're trying to create. You're literally trying to create a string. I'm trying to create a string 1. It's literally a string 1. I'm not going and say, the next way you could create a string is using NSstring here, allocate some memory for it, and initialize it with some string, which is still a string literal, but it's more work here. Right? That's also valid. But that's not what we want to do. Same as in Swift, if I tell you to create me a literal array, you just create an array of whatever the objects are, Bob, 1, whatever. That's a literal array, as opposed to just creating an empty array and then adding objects to it.
Okay.
All right, cool. You get your name on the board. Great. All right, now I think we are good. We want to print out name. So we want to say something like the person name is. Who wants to volunteer and help me here?
I'm down.
Start with
We went together?
Oh wait.
Let's go, Brandon.
go, Brandon.
Okay. Let's get this teamwork down. So I guess it's NSlog, right?
NSlog.
So we want the name. I guess we would
You
do.
could say the person's name is Bob or whatever, BN.
Here's the name again. Okay, so we'd start with at and then quotes again.
At and quotes again, always the default.
We'll write the person's name is, and so that was an I. Next would be the percent symbol, and would we use the, what's it called? The symbol on line 32. I don't remember what that is.
The symbol on 32?
Yeah, right before name. I don't. Do we?
Oh, that's a pointer, right?
It's a pointer. Okay.
But just to let you, that's fine because we haven't seen that particular modify or format specifier for strings. But basically, you could use at here, the at symbol, and then you pass in your string name, which is name, and then don't forget our semicolon. So for strings, for objects, it's the at, just at symbol. For integers, it's I. Or you could also use D as well for digit. But for strings, I'll just say at here. Cool. Good. So let's go ahead and run that and make sure it works. The person's name is Bien. Awesome. Let's just put in our dot here. So the person's name is Bien. Everybody got that printed?
Yeah.
All right, cool, awesome. So let's keep going down. Let's take a look at mutable. So everything that has like NSstring, for example, has a mutable string. NSArray has a mutable array. So there's NSstring and there's NSmutable string. What that means is if I take bien as a string, I could add more strings to it, right, using functions. So I cannot do it with an NSstring, but if I want to mutate, meaning add to bien, I need to use an NSmutable string. So what that looks like is, let's just say mutable string here. We'll create a mutable string. We'll say NSmutable string. What are we going to add here? We'll just say language for now. And language, we'll say NS. This is the first time we're probably going to take a look at this. We'll say NSmutable string, the type. Now in Objective-C, you get your hands dirty, meaning like you're really seeing everything you're doing, as opposed to Swift. You want to get an array, you just say, you just create array, right? You're done. But here, I need to allocate for this particular string that I'm about to create. I will allocate memory for it, right? I'm going to allocate memory for it, whatever memory it needs. I'll put a square bracket. That's the first time we can look at square brackets, right? Yes. So open square bracket, mutable string, alloc means allocate memory. And then after this last bracket, I type in the word init initializer. And this has many initializers, right? There's init with string, there's init with coder, capacity, format, data, a bunch of initializers, right? Here, I'll just say init with, actually, let's init with string. So go up to init with string. You could initialize it with a default string. In my case, I will add, let's just say the language. Okay, so we have our string, the language. Again, just to go through this, how many square brackets we have here so far? We have 4. We have our inner brackets, which allocates memory. So you allocate memory first for this object. And then you initialize it with whatever initializer you want to use. If you don't want to use a default string, you just say init, meaning I'm not going to have any default string. Or you could initialize it with a string. Any questions so far? How do we like the syntax?
This one seems a bit trickier. So what are you doing? Why is there so many brackets?
Why there's so many brackets? What are we doing? Basically, we after the initializer that has a string, right? We want to initialize this mutable string with a default string. So that's the syntax for it. Allocate memory and then initialize, call the initializer.
Wait, so
you guys going together and you guys stopping together, huh? Bien and then Sering.
all right, so just to understand the what's going on, it's allocating memory on the PC and then is basically initializing that same data type, correct?
Yes, allocating memory on the heap for this object.
And then start it up.
And then start it up, yeah.
So it's like putting gas and then start the engine.
Yes. Yes, as opposed to in our perfect world of Swift, we just get in the car and we say we drive.
It's starting it up and putting the the language in its place also, right?
Yes, because now if we print language, we should see the language, correct?
Correct.
All right, very good, excellent. Cool. So again, in Swift, if you want to do something like that, you'd say var language, and then you would just do the language, right? And then you would do things like language. Then you could add whatever you want to language. You could do plus equal. The language is Swift, something like that. Or the language is Objective-C in our case. right? Or you could say append string. Language that append, and then you could pass in some string. The language is Objective C, right? Again, which syntax we rather? One says he rathers 39.
Wait, what?
All right, cool.
Oh, well,
I like line 40.
the only thing I don't understand is like we have square bracket. We have NS line 39, NS mutable string alloc within square brackets, space init with string. So normally when you have like space something.
You're asking all the right questions here. So we'll come to that in a second. That's like calling functions, right? We'll come to that in a second. We'll come to that in a second, because what happens here, good question. You have the object here. In that case, you have the class, and the class itself is calling this class method. So that's how you call methods, or that's how you call functions, an Objective-C function. The function we called earlier was a C function. So I just called it like we do in Swift. But if I'm calling an Objective-C function, we'll come to this, but calling an Objective-C function, it would be something like this. So it would be the instance or the class, right? And there would be the method name. So that here on 41 is very similar to what we have here. You with me, Juan?
Right.
Or, so this is an instance. Again, we should all know what instance types are, right? When I say an instance, I'm calling the method on the instance. We know what that means?
Yep.
Okay, cool. And then here, if I'm calling it on the class itself, like we are doing right here, I could say class method name, like this. And then this 42 would be exactly what this is here, because this is on the class itself.
Okay. So the square brackets is part of the syntax when calling a
function.
Calling a function. Okay.
Very good. Very good. I'm tempted to do it today. Actually, we can, because that's fine. We'll take a look at it today. We'll take a look at it today, so we could take a look at what that looks like. All right. Thank you for bringing those questions up. Very good questions. Cool. So where are we? We just want to print, not just print, but we want to add more things to language, because the whole point of making a mutable string is to add more things to it. And in Swift, if we want to do this, we do var language and we add things to it. Everybody with me?
Yeah. Part of making a mutable, yeah.
Yeah, so let's do this then. Let's go ahead and say, I want to add, actually, we'll take a look at the square bracket function calls right now. I have my language and I want to add things to it. So append is the function. So we don't have to like write our own function right now. We'll take a look at it right now. So what you want to do, let's back up again. I want to add, very similar to what I have here, the language is Objective-C. I want to do this in my print statement. But before we do that, let's actually print what language is right now. So NSlog @ symbol semicolon. I want to print language. Let's just print language, what the language is right now. And the language right now is just the language. Let's just run this. And here we have language is just the language, right? Or let's just put message. Okay. Now I want to add more to it. I start off with, as one started pointing out, if I want to call a function, call in functions in Objective-C. You start off with, must start off with, open square bracket. Okay. Then you put the instance or the class name. In that case, the instance we want to call the function on is an instance of a string. Everybody with me?
Yeah.
Yep.
So here we'll say language, and then we want to call, there's many functions on a string. we type in append. We come to append format, right? We still have our string applying, we have our string appending path component. One thing, if you haven't seen yet, which I know you have, everything in Objective-C is more verbose. The names of the functions are longer. Everything is more work to type. So already we're appreciating Swift even more. So here we'll say append, and then it expects some string, and then we'll put in our string, semicolon. What string do I want to append? I just simply want to say the language space is Objective-C. Okay. So if I print, let me just copy this. Actually, we're learning, so let's not copy paste. And then I'll say nslog type message again and put in language. And now for print, we expect to see the language is Objective-C on the second print statement. Let's go ahead and run. So the first time we have the language, second time around, we have the language is Objective-C. Everybody got that printed out? Awesome, great. Great, great, great. Let us take a look at arrays, and then I think we will move into, let's take a look at arrays, and then control flow is very similar. We'll come across that, that's fine. But let's move into arrays first. Yeah, let's move into arrays. Okay, cool. Any questions so far? Everybody still on track with us? Go ahead.
One last thing. So if you, back to line 39, so if this is the, we're calling a class function with NS mutable string a lock. And then, so what's the relationship with like init with string that comes right after it? So is that?
So init string is an initializer. Like we have many initializers on strings, for example, like you could create a string from many, you could create a string many ways using different initializers. Here, we just decided to use init with string to give it a default string. But that's a method that expects a string. So on the return, we call a function again. This returns us a new string, right? It returns us, right, a new string or a memory for a new string. And then on that, we call a function init with string that returns us a string with language.
Okay.
So it's like embedding multiple calls.
So it's like nested or
Yes,
a helper
yes,
function within a function?
Exactly, exactly.
Okay.
You get the result, call a function again on that result.
Okay.
Okay.
Cool.
And I have seen more brackets than this, so.
And Objective-C?
Yeah.
Yes.
That's unfortunate.
Hey, that's why we have Swift. I'm telling you, when you guys go home, well, you are home, but you'll see how much nicer iOS development became with Swift language. And now with Swift UI, that's what people are saying with Swift UI. When they look at UI kit, they're like, really? You have to write all that code to get a button on screen? So just write one line of code and I have a button with animations, literally with animation. So it's good.
Yeah, I think I saw a post on LinkedIn about how a manager switched over his team to Swift UI and they're like, oh, we all love it now. Like,
yeah, they love it because they're saving a lot of time. Saving a lot of time until they have to go back to UI kit. Because the thing they're trying to do is bug in Swift UI. But we're getting there. We're getting there. Okay, cool. So let us go to arrays. Again, we have an NSArray in Objective-C. Same, we have an NS. If we have an NSArray, we'll have an NS what? Like we had an NSstring, we had NS mutable string. If we have an NSArray, we'll have an NS.
Mutable array.
Mutable array.
Mutable.
Very good, very good. So let's create an NS array here. I'll use the same example I had, which is fine. Programming stacks. And here we'll create a literal array. When I say a literal array, I'm just populating it with the contents that it needs right away. Here, I'll start with an @ symbol. So already we've seen a lot of things starts with @ symbols, especially when we're talking about literals, right? Literal string starts with an @, literal array starts with an @, and we'll see the same thing with dictionaries as well. Okay, so there we are. So we have an empty array, but we want to put objects in that array. We'll start off by, we want to make it a string array, right? So we'll say we'll put in what language? We'll start with Swift. Let's start with Objective-C. Okay, let me stop here for a second. That won't tell us what type it is. That's the next part of Objective-C versus Swift, where Swift, we love it. So in Swift, if I create something like this, and I say, I want to make it mutable, right? So I'll say var mutable stacks, right? And then I do this. I was about to do a semicolon. And then I do Objective-C like this, right? What type of array is this?
String.
Array of string.
Array of strings. Very good. So this is an array of strings, right? Awesome. Very good. Thank you. Now in Objective-C, you could put multiple things in here. Like I could put 45, same as Swift, right? I could put in some Boolean value like that. Or true, rather. What is it like my 45? Put a number. Okay. You could mix types here because the compiler doesn't really care about what type that is. It's not type safe as Swift is type safe. Okay. So again, that's a big benefit of Swift. Swift is very type safe. The minute I did string like that, the compiler would infer that programming stacks is an array of strings. So if I was to add more things in that, I would get a compiler error. But here, you're not going to get a compiler error, right? Like if I was, when I do mutable array, I'll show you guys what I meant. But basically, it's not type safe like Swift is type safe. Okay. But here, let's just continue on. I just wanted to point it out because this is a big difference. Let's keep adding some languages. We'll say Swift. We'll add Python. We'll add Java. That's fine. We have enough to go on. So we have our array of languages here. Next, let's take a look at iterating through those objects. Let me take out Bob here. Again, in Swift, you could do something like for language in programming stacks, copy, paste here. And then you could just print, language like that. And we're good, we're done. I want to do the same thing in Objective-C. How do I do it? Let me do it down here. So we'll say for. Parens is required. Okay, so for, same for here, but now we have parens that's required. Within those parens, you have to specify the type that you're about to use or the type of things you have in here. The type of things we have in here, we put strings in here. So let's say NSstring. Don't forget our asterisk, our pointer here. And then we'll give it whatever name we want. In our case, we'll just call it language in programming stacks. Everybody got that down? I think Brendan is loving Objective-C.
I thought there was going to be like 80 square brackets for this for
Oh,
loop.
yeah. Thankfully not. The only thing that's different is this here that I'm highlighting, and the parents is required, right? So if I move my parents, what happens? Expected open parents, right? So that's required. Parents are also required on if statements, right? And such. So here we are good. The rest is pretty much, we're just gonna NSlog the results. So we'll say NSlog, and we will say the language is whatever the language is. Now we've seen what we have to do here. What's the placeholder? What's the format specifier I'm using here?
%A.
%A, very good. And then comma language. And if I run this, it's gonna iterate through my stacks and print the language is Objective-C, language is Swift, language is this, language is that. I guess this is a good place we could probably take a look at what if looks like, which is the same thing, minus like the requirements of the parents. So we could say something like, instead of printing all the languages, we could say something like if language is equal, does double equal work? Let me double check. If language equal to, it's complaining already actually. What is it saying? Direct comparison of a string literal has undefined behavior. Use is equal. Everybody sees that? All right, again, the little things we take for granted in the Swift language. Here, we gotta call a method on this, right? Because there's a method called is equal on string, okay?
What if you use 3 equal signs?
That's object equality. It checks to see if the objects are equal, and that doesn't even exist here.
No.
Oh, really?
So we have to use the method on it, and we'll use the method on a string called is equal, or the property is equal. Is it a method or is it a property? It's a method. So is equal, and then whatever the thing is here, and then don't forget your square bracket, like that. And then in here, I will say language. Well, not language, but what are we looking for? Swift. And then we'll print NSlog best language ever. Unless Brandon wants to stick with Objective-C. Language. Cool. All right. Let's build and make sure it doesn't have any errors. And let's go through this. So we have our for loop, expected semicolon, right? We have our for loop. This is required here to specify what type you have. We have our if statement, checking to see if the language we're currently looking at is Swift. And again, you just saw double equal sign doesn't get us what we want, doesn't work. So we have to use a function. This is a function, right? This is a function here. I'm calling this function on language, right? In Swift, that's not what we do. We just say language equal equal. We're done. So here, if it's equal, we want to print out best language ever. Now let's run it and make sure it works. Oh, actually, let's get the language name, right? How do I get the language name? Well, I'll say @ symbol is the best. Yeah, that's better. And then I need language here. Cool. Run that. Swift is the best language ever. Everybody got that printed? Or did it print Java for you?
Objective-C, that's what he said.
Objective-C, very good, very good. Hey, I still love the language. I guess I just like pain. What can I say? All right, cool. So we got that. We got a lot of things going on. Any questions so far? Because so far, I think we have gotten a good intro into this. Let me see if there's any questions you guys could start attempting. Figma, no. After this lesson, let's see. You definitely could do question 1. Create an object. Okay, so question 2 you cannot do yet. Question 3, question 4 you could definitely do that. Question 5, write a program that calculates the sum. You could do that as well. So let us take a pause and equip you so that you could do question 2 and 3. Because question 2 and 3, create an object. Yeah. So let's take a look at how can we create objects or models or whatever we want to call them in Objective-C.
Yeah, I've got a quick question.
Yeah.
About how do you call the language that's outside of the scope of that function?
The language.
Like, because you already declared language.
Wait.
Right?
Oh, well, we have a function here that's outside of the scope of main, right?
Yeah, I'm talking about, like, if you scroll down.
What line?
And right there, you have that mutable function or language right there. Yeah. So you have that language. What if you wanted to call that language inside of your function? Like if you scroll down now, like if you
I could call it. I could print it anywhere here in scope. I could print it here.
And like, yeah, but aren't you declaring like you have language there?
Oh, remember locally scoped, right?
So yeah. So how does?
Yeah. Remember locally scoped, right? So language here. What do I have up there? Languages, right? Oh, language as well here. Language here. This is locally scoped. So this language is going to be the current one of that scope.
Yeah, so I'm saying, what if you wanted to use the?
Oh, then I would have to just like call it a different name because I can't say self.language.
Yeah, I guess that was my question. Is this?
Yeah. I can't say self because it's not on an object. It's not an instance of an object, right? Like if I was in a view controller and I have an instance variable language, I could say self.language and that would differentiate. That would differentiate it here, right? That would be very good.
So you'd have to rename it.
Yeah, exactly. Good question. Good question. Very good question. Cool. So let us create files. We have 10 minutes, 7 minutes. We could do it. Let's just create a person. We always like person. Person is good. So now this is the first time we'll actually create files. So let's create 2 files and then use that file in or use that instance, create an instance of that object in our main and then just test it. So let's create 2 files. So right click on main, new file. The first file I want to create is a header file. I mentioned header file earlier, but we'll take a look at it. So create a header file, click on header. Everybody sees header. Nope, nobody else on camera. I feel lonely. Brendan, come back. So header file next, and we'll call this, we'll save it as just person, no extension, just person. And we'll click create. And we'll create a next file. So new file. And this time not header. This time we're gonna go to Objective-C file. Do we see Objective-C file, top right? So the first one we created was a header file, .h. It gives us a .h by default. And the second one is an Objective-C file. It gives us .m as the extension. So click next and call it the same thing, person. And let's take a look at those 2 files. Let's actually drag those 2 files above main. Not like it matters, but you know. First file we created was a header file, .h. Second file we created was a .m file. So the best way to explain this is actually just getting our hands dirty with code. So in the header file, we don't need any of those things for now. So just delete that. So it should just be empty. I'm in the header file. I'm in the .h file. In Swift, if you tell somebody create a person object, they create 1 file called person. Everybody with me?
Okay.
In Objective-C, if I have to create a profile view controller, it's going to be 2 files. One is going to be profile view controller.h, and the other one is going to be profile view controller.m. Okay, let us keep going. So in my header file, I will start off by typing @interface, press enter. The class name, is person. Person inherits. All our objects needs to inherit from NSObject. So person needs to inherit from the superclass of person will be NSObject. NSObject build. You have no errors. Perfect. So person is a subclass of NSObject. Everything you do inherits from NSObject. In Swift, we don't care about this because by default, it inherits from NSObject. Okay, cool. Now our person for now, let's just keep it simple. We want to have, let's keep it simple. What's the simplest way? Actually, just create a property. I want to create a property for this. Do I want to create a property for this? Let's just create let's create a method. Create a method and we'll see what methods look like. We'll create a method called info, just like that. And in info, we'll just print something for now. To keep it simple, we'll just print something in info. Again, in Objective-C, the header file is where you just name the function, but you don't implement the function. Think of protocols. In protocols, you say what the thing is, but you don't implement it. Everybody with me? Okay. Now we'll keep that for now. We'll go to the implementation file or the M file, the .m file. In the .m file, here we're gonna say @implementation. And then the class is person. Okay. Now it's already complaining here. It's saying class person defined without specifying a base class, add a superclass, and all that stuff. But I need to import my header file, which is person.h. Okay. A lot of work so far. Sorry about that. I did not code that. What's that?
Pretty nifty.
Yes, a lot of work. Okay, right now it's already complaining. It's saying it doesn't find info because we said there's going to be an info implementation. In the header file, we said, hey, we're going to have some method called info, but we haven't implemented it in the .m. So we need to go ahead and implement it. So here I'll say, can I just type in info and press enter? Yes, awesome, great. So here I could just type in info, which is the name of the function we said we're going to create. And now we need the body of the function. So here is where you have the body. You don't have the body in the .h. The .h only tells you, or the person using your API, what's available. Think of the documentation. Like when I go to Apple's documentation, for example, and I go to string, right? And I see, okay. When I go to string, I see, okay, there's some function called remove. I don't see the implementation of remove. Everybody with me? Okay, so it's one you were saying? Oh, Ben. Anybody? Nobody was saying anything.
He just agreed.
No, I was just.
Okay. In the .m, let's go to the .m here. For now, we'll just say nslog. We'll just print something. And then we'll continue next week for sure, because we're just about the time where we have to stop here. Info, I'll say this is a person. Just like that. And then again, make sure you have important person here, the .h, right? Make sure you're in the implementation file, and that's where you implement it. Let's talk about the function syntax for a second. This is an instance. Again, I make sure that we all on board, we all know what instance methods are. This is an instance method. This is an instance method. How do I know that's an instance method? The minus here. Minus, and there's some data type here, or return type rather. Right. So this is the instance method. How do you know in Objective-C? by the minus sign, right? Anybody know what a class method looks like?
Would it be the name of the class first and then the return type and then?
Close, but we have plus, and then
Oh.
we have we have the return type.
Of course.
We have the return type like that, and then we
I
have.
was wondering why you called it a minus. I was like, isn't that a dash? A
Oh, yeah,
dash? and
yeah,
then-
yeah. So this is what a class method looks like, and this is what an instance method looks like. An instance method works on the instance, right? All right, so let's make that work, and then we're gonna stop here. So everybody compiles no errors. Brendan, was that a no, like you're not compiling, or was that a no, I have no errors?
That was no errors, no.
Okay,
Well,
This is a no.
I just want to
Objective-C.
say,
awesome. Yes, one
my everything except Zoom kind of
works.
froze for some
Froze.
reason.
Okay,
Yeah, a little while ago, so I can't test any of this right now.
okay. All
Like I
right.
tried closing everything, but it doesn't even want to close. So I think I have to restart my computer, but I don't want to do that mid
Okay,
lecture.
I should be able to post the video later.
Okay.
All right, cool. So let's test our info. Go to the main, and then let's test our info here. Now, at the bottom of my for loop somewhere, I want to create an instance of person. Because the only way to call our method is to have an instance. Everybody with me? All right, so create an instance of person, and then we want to call info. Cool. How do I create an instance of person? Anybody? We've seen creating instances in Objective-C so far. We created an instance of an array. We created an instance of Mutable String. Anybody want to give me any? What's that?
The type, which is
the type. Okay, the type is person. Wait, but person is not coming up.
Don't we have to import it?
Ah, we have to import it. Thank you, sir. So I need to import person before I could use person. So here I'll say import person .h. We always import the .h, not the .m. Two differences I want to point out here. Classes, APIs inside of iOS itself, by iOS itself, is angle brackets. Like foundation is angle brackets. Your own types is quotes. Everybody with me? All right.
Okay.
So now we have person. Christian says, I have person, and then I'll have person is an object. Any object, you need to prepend the name or the variable name with a pointer. I will just say person. I could name it something else, like I could call it Eric, or the object Eric. What else? Think square brackets. I want to allocate memory for this person, and I want to initialize it. How do I do that?
Right. You could do the square bracket.
Square bracket.
Person.
Person. Allocate memory for that person, and then
init.
And then init. Right now we have only our default initializer. That person could have our own initializers. We'll talk about that next week. I don't want to do too much today. We did a lot already. So here I could just initialize this object, and now on Eric, I could call our info. So Eric info. And if I run my code, I should see my print statement saying this is a person here.
Yeah.
Okay. So this is a very good place to stop because we saw a lot today. Some of the questions you guys could do already, I highly encourage it. So like next week when we meet, we could keep going and then see where we are at the end of the day. So far, so good.
Sounds great.
Awesome.
That's good.
Awesome. So that's our brief intro to Objective-C. We'll continue next week. And next week, we'll just continue from where we were. So you could see more of like creating properties and stuff here. We could have an instance, like we could have an initializer for person, which looks something like this. Instance type init with name. I could have some name here, but we'll take a look at that next week. We could create our own initializers, something like this, and NSstring. And then I'll just copy this, but we'll come back to that next week. Don't worry about typing that in right now. And then here, I'll have my initializer. I'll just return self for now. And then back in main, instead of creating init alloc like this, I could do person Christian like this, and then I could do person allocate memory for that person, and then use our default initializer with name like this. So this will give us more flexibility. But we'll take a look at that next week. Everybody with me? Cool. All right,
Yeah,
great.
creating an initializer. Cool.
Yeah, so that's like how you see the init with string got created earlier here. Cool. Awesome. Just review what we did today so that next week, we'll do that again next Thursday. Is everybody good for that next Thursday to do this again?
Definitely.
Yeah.
All right, so let's do that next Thursday. And then if we do it one more Thursday, that means we could get deeper and then populate some sort of table view with web API.